Welcome to another video of Daishinfinity. In this video, we're going to talk about the proof of implication. It states that A to B is equivalent to not B to not A, and that is also equivalent to not A or B. And this implication is very important, and this equivalence is very important to understand logic in order to use this as a proof in general in mathematics. For example, not B going to not A is used for contraposition. For example, if you want to prove that the square root of 2 is irrational, you have to use this as a proof technique, and that is why I want you guys to listen, and let's prove this formula. Before we dive right in, we have to say what a normal statement is like. So a statement, a mathematical statement, is a mathematical object which is either true or false. Now, if it's true, I will say let true be T, and if it's false, I will say let false be F. So let's say a statement may be A. So A is a statement, and A can be true or false. So true is something you say about a statement, which is element of A, and false is also an element of A. And the same thing goes for B, where true is also an element of B and false is an element of B. So we would have to combine A and B. If I have two statements, how many combinations of true and false would I have? And this is what we're going to do. We're going to write the statement as follows. We're going to write A and B as normal sets. So these are called sets, and in those sets we have the true and the false as an element of A and B. And then we're going to combine them. So we have true true, we have true false, we have false true, and we have false false. So where A is true true for false and B is true false true false. And this we can write it in a small list. So let's use A here, and let's use B here. And then we're going to write true, true, false, false. And one time where B is true, one time is where B is false, and here true and false. Now, A going to B means that if A is true, or if A is a statement, then B is also a statement. Now, if A is a true statement and B is a true statement, so true going to true, then this implication or this implication will be true. If something true implicates to something false, then the implication will be false. And the other way around, if something false implicates to something true, then it will be true. And if something false goes to something false, then it is also true, because if something is false and it will become true, then if something is false and then the false statement implicates that it's also false, then we have the same thing on both sides. That's why it's true. Maybe it's a bit difficult to understand this implication, But after a certain time, you can understand what A implicating B really means. Now, for us to understand not B implicating not A, so negating A and B, we have to negate A and B first. So negating A and negating B. Now, if we negate A, the negation of true is just false, and the negation of false is just true. So we can have false, true, false, true here. And then we can write negation B implicating negation A. And we can show that this should be equal or equivalent to A implicating B. So if something false goes to something false, then we have the same on both sides. So this is a true statement. If something true goes to something false, then this is also this is a false statement, because something true goes to something false. So the true statement was indeed a false statement for A. And something false going to something true should be true, and something true going to something true, which should also be true. So as you can see, these are both equivalent. Now, the last one we have to prove is not A or B. In order to prove not A or B, we can first of all write A or B. And if we write A or B, it means that at least one of the statements should be true. So for the first one, we have two true statements, so it is true. The second one is true false, which means true that we already have one true statement. That is why we have true when we have A or B. And false true means also true, because that is also a true statement. And false false, there is no true statement, so this is just false. And in the end, we can just use this logic to continue our list and write not A or B. And this should be equal to this one. And if it's equal, then we have proven that those three are equivalent to each other. So not A, I'm going to use another color, and B are here. And we're just going to see that false, true. So at least one of them is true, which is B in this case. So this is also true. As for the second one, we have false, false. So it should be false because we don't have any true statement. And in the third one, we have true, true. So we have two true statements, which means we have at least one true statement. And last but not least, we have false, true or true, false. How you read it, it doesn't matter from left or right. We also have at least one true statement. That is why it's a true statement for not A or B. And that's why we have just proven that the same thing exists here and on the other two. So we have this, this, and this. So they are all equivalent to each other. And that is why we have just proven that A implies B is equivalent to not B implying A, not A, is also equivalent to not A or B. I hope you really enjoyed this video. Please like and subscribe. If you have any questions, please ask me. And we will see us in the next Daishinfinity video. See ya.